we have to share the planet with other species. Typically what we do is when we really need certain species, we simply domesticate them. What is it to domesticate? To take control of their genes. We domesticated certain plants. When you compare, remember that photosynthesis converts solar energy into what is called biomass. Biomass is simply a fancy term for flesh, vegetable flesh, animal flesh. Perhaps the term sounds a little too poor now to biologists, so they came up with biomass. What we have done since we began breeding plants and animals is take over the genetic system so as to redirect biomass from the unedible parts to the edible parts. So when you look at, for instance, the ancestors of maize or the ancestors of wheat in Mesopotamia, you don't see something recognizable. You certainly don't see a fruit like a corn cob with like all the humanly edible parts kind of like jumping at you. You know, like sexy corn cob. They look like, oh my God, who's going to eat that, man? There's no way I'm going to eat that. But through successive generations of fiddling with their genes, you can begin redirecting biomass from the roots, from the leaves, from cellulose-loaded stuff that we cannot digest to the parts that we can digest. So we take over their genetic systems. We also take over the genetic systems of animals. And what we end up is with something, a pyramid like this. A pyramid in which domesticated plants are at the bottom. Domesticated animals are here. And humans are here. In other words, we use domesticated plants to capture solar energy into sugars. Then we use domesticated animals as channelers or as focusers of biomass into humanity. Think, for instance, of cows. Cows eat stuff that we cannot eat, cellulose in particular. But they convert cellulose into things that we can eat, such as milk, flesh, not to mention the kind of work that you can make a cow do in terms of being a beast of burden. That is, we can tap into their muscular energy in addition to eat them. And they basically transform what is humanly unedible into something that's humanly edible. And we have made sure that these animals are there focusing biomass on us by taking over their genes. Pigs are even more efficient biomass transformers. If a cow transforms about a fifth of what it eats into humanly edible stuff, a cow transforms something like a pig transforms 4 times as much as a cow. The problem with pigs is that they also eat carbohydrates and other forms of food that we can also use. So we use them mostly as biomass hard disks. But this is particularly true during colonialism, when in the early days of a colony, there's an excess of grain and no way of pickling it or storing it in any way. You feed it to the pork, feed it to the pigs convert it into bacon and yummy ham and stuff, and they live 3, 4, 5 years while you're using them as storage devices. Then eventually you eat them. And they are now playing the role of focusing biomass on humans from solar energy. Now, the problem with this is, of course, that you only have control over the genes of those plants and animals for as long as you take care of their breeding habits day to day. The moment they escape, they become something else. They become feral. This particularly of animals. And this happened several times during colonial times. Cows went feral in Argentina, becoming this wild cattle that in fact made human habitation of certain areas impossible. They reproduce and they reacquire their migratory habits. They kind of shed their shackles, so to speak, shed their human shackles and became wild again, went feral. Pigs were used by pirates to seed islands. So because they knew that pig would eat just about everything, you could just go and stop again in that island, and you would have lots of little pigs that you could it was a way they would seed islands with pigs, if you can believe this. And in certain parts they went feral too. The razorbacks in Australia with their tusks and their stringy hair and their nasty habits are descendants, feral descendants of European pigs. This social construction of biomass, so to speak, this culturization of animals by taking over their genes needs to be watched out and enforced day to day. The moment some of these guys go wild, the moment they start doing their own thing, the moment they start mating without a human supervision, they start doing their own thing. And they start affecting all the humans somewhere else. Now, this is, of course, much more the case with microorganisms. The problem with microorganisms is that they evolve way faster than we do. Evolution proceeds at a speed that has to do with how long it takes you to reach sexual maturity. That is, how many years pass between your birth and the moment where you can pass your genes. Because from the point of view of evolution, those are the only 2 points that matter. The moment your parents pass your genes to you, and the moment you pass your genes to your kids. Everything else in between counts insofar as it was reflected in that reproductive success, in that reproductive rate. If we take, say, 12 years to reach sexual maturity, and then there are cultural mores and customs that may postpone it even farther, well, how can we compete with microorganisms, some of which can reproduce every hour, some of which can reproduce once a day, some of which can reproduce once a week? There's no way. There's no way. So the question is, how did mammals in particular manage to evolve who are being bombarded by viruses, bacteria, fungi, and all these other microorganisms constantly? Basically, we live immersed in a soup of microorganisms. Well, what we did is, since we could not out-evolve them, because we evolve way slower than they do, we out-simulated them. The immune system in our veins is basically a simulation of evolution. Antibodies are the creatures that evolve, and antigens, the part of the microorganism that your immune system can recognize, serve as a selection pressure. In other words, there is just like there are computer simulations today called the genetic algorithm that can simulate Darwinism in the computer, and instead of animals and plants, you have virtual animals and plants, that is, computer programs that mate and leave descendants and then evolve. Well, we have a genetic algorithm implanted in our bloodstreams. It's called the immune system. We had to simulate evolution for sustainability. This was kind of sustainability by simulation. And that is what the immune system is. But the immune system the story of the immune system doesn't stop there. It goes on to have very specific social effects. Let me erase this and draw one more diagram here. In particular, a population of humans coupled to a population of germs forms a dynamical system that can have three different, or rather, let me just put it this way, two different states. The epidemic, in which the microorganisms, of course, reproduce faster than we can control them, make copies of themselves way faster than we can come up with quarantine procedures or medicines or antibiotics or anything like that, and kill us all. Or the endemic state. If the epidemic state is the end of sustainability insofar as microorganisms are concerned, the endemic state is one in which we can coexist with the microorganisms. It happens this way. Epidemics usually occur in waves, and they leave some survivors. So say a city gets attacked by a particular epidemic, say an epidemic of measles or smallpox. Measles and smallpox are considered, they are very virulent. They are considered today biological weapons. Smallpox is supposed to have disappeared from the planet. Kids don't get vaccinated against smallpox anymore. But there are definitely biological warfare laboratories out there that have smallpox. Smallpox came to Europe via the Roman Empire. Troop movements brought it into Europe from India. And it caused epidemics, very deadly epidemics. But with every epidemic hitting a particular town, in rural places, it kills everybody. But in towns, there's enough people packed in there that these diseases can leave survivors. And of course, the survivors now are immunized. They are now running a simulation in their bloodstreams that allows them to recognize smallpox and not to get sick from smallpox. The second epidemic hits, kills some of the new babies, kills some of the new children, but the immune people stay. Immunity is not heritable, so the next batch of survivors is quite random. After 3, 4, 5 epidemics, there's enough survivors in the town that only newborns are the only ones that are not immune to that particular disease. That is the moment, it's a critical point between the epidemic and the endemic state at which a particular disease such as measles or smallpox becomes a childhood disease. You know, everybody knows measles and smallpox, viruela y sarampión in Spanish, as diseases that only newborns get. But it's not as if these are like evil microorganisms that, you know, are out there eating babies or something. It's just that as it happens, because immunity is not inheritable, that at some point, once accumulations of immunized survivors have accumulated to a certain critical mass, only those who have never experienced the disease are subject to that disease. And the diseases become childhood diseases. That is the endemic state. And this is the sense in which certain diseases are specifically urban. In rural places, there's not enough density of people to guarantee this effect. It might occur in some very large villages because it's all really a statistical effect, but it tends to occur much more in highly populated, densely concentrated settlements. In other words, cities. And so cities are, in a way, epidemiological laboratories. And European cities in particular have many of those endemic diseases already prior to this point. Smallpox and measles had already become endemic in most European towns at the time. But what happens when you send some of those Europeans to a place where smallpox and measles have never occurred? Well, you unleash an epidemic. Right? You take people from an epidemiologically scarred place to an epidemiologically virgin place, and what you create is a huge epidemic, which is basically a germ warfare, albeit in an unconscious kind of way. That's exactly what happened, or at least one of the things that happened in Mexico City when the conquistadors arrived. We need to learn to coexist with microorganisms. We're not going to be able to take over their genetic apparatus just like we did with pigs and cows and horses, because microorganisms not only pass their genes downwards in a vertical flow, they also pass their genes horizontally through what is called jumping genes or other kinds of vectors through which they can share genes. The majority of diseases known to medicine today has at least one strain that is resistant to antibiotics. How do they do that? You know, we thought in World War II, when we began milking penicillin from a bacteria, not literally milking it, but putting them in large vats, and basically we were extracting this natural penicillin, which was a weapon that bacteria used against one another, to fight them. Today, of course, penicillin is synthetic, and there are other antibiotics, but we're not exactly winning that war. We push microorganisms one way, they push another way. And so we have not managed to find some way of peacefully coexist with these microorganisms in a way that makes us understand what sustainability means in this respect. Think, for instance, of all those new detergents that are antibacterial. Yes, it's great not to have that sponge, in your sink smell terrible. You put little antibacterial soap, bingo, you kill all those nasty bugs. But by killing those nasty bugs, you may be killing your own bugs. Remember that your bodies are ecosystems for microorganisms. We're populated and colonized by microorganisms. Every orifice in your bodies is. But these are microorganisms with which we have developed a symbiotic relationship. As long as they stay in their orifice, and you don't start transporting them from one orifice to another, they are friendly. And most importantly, they crowd out the bad guys. But we start overusing those antibacterial detergents. We start using this relatively primitive approach to coexistence. We begin killing our own microorganisms. We begin opening up spaces in our ecosystem, niches in our ecosystem for the bad guys to begin inhabiting. We make ourselves more vulnerable than if we allied with certain microorganisms against others. But that idea, that aspect of biological sustainability, has not been quite understood yet by people.